Everybody, it's Tyler here at the championship checking team number 5172 Gators. This team has been on our radar for a really long time. In my opinion, the best team to ever come out of Minnesota, and definitely a powerhouse in the Midwest area as well too. You've got to check out this incredible scoring machine as it goes through each of the different mechanisms. But to help me speak more about that, by the way, I have Sawyer, Vincent, Ray, and Berlin. And on here, some upgrades coming in from their events as well too. Hopefully you saw their upgrade video as it came out. But just a well-packaged machine. 5172 has been one of the best teleop scores for a long time here in First. So can't wait to learn more about this robot coming up here on Behind the Bumpers.
Your destination for First content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. Stryker's commitment to medical device technology innovation has made it a top career destination for those in First. First alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. First Updates Now is supported by the Milwaukee School of Engineering. MSOE offers week-long summer camps where high school students get to preview college by living on campus, exploring engineering programs, experimenting in labs, meeting with professors, and participating in fun group activities. Are you ready to experience STEM at MSOE? Visit msoe.edu/summer to learn more and register.
So before we get into that cargo area, Sawyer, your team switched over to Swerve this year, and I'd love to just hear more about your experience of going from a tank to a Swerve, and then maybe any advice for teams looking to do the same thing.
Yes, as you know, this is actually our first year using Swerve drives, and it's been interesting switching over from the usual tank drive to Swerve drives. And my personal experience driving them, I think they're a lot of fun. The thing about Swerve drive, it's very maneuverable. You can go anywhere, 360 degrees. It can rotate. It's amazing. It's actually a lot of fun to use.
So can you run us through your controls on here, like how when you're actually controlling the robot, like what does what on it?
Yes. This left joystick here actually controls the movement of the robot. So it can go left, right, forward, back. This actually controls the rotation. So this rotates the robot. Yeah.
And then when you're looking at it, how did you train yourself best? Like, are you using a field-centric drive, or how do you go about? So how did you go about training yourself to kind of get your mind ready for that versus tank?
Just a lot of practice. It takes a lot of practice to get used to it.
And then what advice would you give the teams that are looking to go to Swerve for the first time?
I would say try it out. It is a lot of fun. When you're using Swerve drives, you're just going so fast, and it takes time to learn. It takes time to get used to it, but in my opinion, it's worth it.
Let's move on and start talking about your cargo journey here. So we're going to bring in Vincent to talk about your intake on here. So love to hear about the general design, any iterations you might have changed throughout the competition season, and how it's been working out for you.
So we have a non-parallel 4-bar pneumatic intake, and it has one of the most important things that what you wouldn't think is at the beginning of the match when it deploys, it plops down this little Lexan this guard, and this really helps the balls from getting over the bumper and into the actual chute. And so at the front here we have a custom foam roller with a carbon fiber rod in the middle, and then all of these mechanism wheels on the front are all 3D printed by ourselves, and we have these bigger ones on the end to just help guide the balls into the middle. And
when you're looking from an intake-wise, so this is a relatively compliant intake that you have on here, right? What made you choose like this versus something super rigid?
The main benefit with having something like this is when there's balls up against the wall and you're going at it faster, it's gonna bounce back in, and that just helps protect it a little bit more than if it just falls down. That's the main benefit I could think of having it like this.
Let's keep moving on, going to your conveyor, and then your shooter. Ray's going to cover that a little bit more. So talk to me about anything you might go into, any sensors or anything like that. And then as we go into your shooter, I'd love to hear, of course, more about your great turret and hood.
All right, so our conveyor on the inside it's pretty much just a ramp that has a singular set of wheels in the middle to push the ball up and hold it in place until it's ready to shoot. We have a color sensor towards the top that allows us to differentiate between the red and the blue balls for this year's game. and say we're on the Red Alliance and we pick up a blue ball, the turret will automatically adjust and it will turn a little bit and shoot it off so it will not score any points. And then moving up towards the turret, we have our turret, which is pretty much completely automatically controlled by the limelight we have on top. On the front, we have our flywheel. It is an aluminum flywheel with blue nitrile tread on it to allow us to grip the balls better. And then it has two brass just counterweights on either side to help the momentum stay up and help us become more accurate. And then at the top, we have just some green Banebots wheels that allow us to cancel out all of the backspin on the ball so that when it gets shot up and then into the hub, it does not bounce out nearly as much as it would have if we left all the backspin in.
So a couple follow-ups on that. So for these the brass flywheels you have on here, are you actually leaving your shooter running the whole match then? Because with that amount of heaviness, it would take a little time to speed up, I would think.
Yes, the entire match, it is constantly running. It does change in RPM depending on what the limelight sees and how far we are away.
And then for your color sensor on there, I see you have some LEDs. Are you getting any sort of feedback or anything like that based on the LEDs?
Yes, the LEDs allow the driver and the operator to know what the robot is doing right now and what it is ready to do. For example, when they are when they show dark blue, that means it is ready to shoot and it is lined up and it is pretty much going to make it if these LEDs are dark blue. If it's a lighter blue, it means that it's close but it's not quite lined up, things like that, so let's know what the robot's doing.
Let's wrap up in your robot. Let's talk about the climber. So you've done some modifications going into the championships here, Berlin. So talk to me more about what's been modified, and then we'll do a little bit of a demo on the type of climber you have as well too.
So for our first regional, we had a climber similar to this, except for these hooks were a little more narrow. And this hook was actually just a singular hook that kind of was like that. And then coming to our second regional, we actually had a total different climber. It was a 4-stage climber with 2 arms here, and it was a really fast climb, but we ended up having some mechanical issues with it. So we ended up switching back to this one, but making these hooks wider so it didn't hit the turret, and then having this hook have 2 different wider hooks so it was less swinging.
Can you run me through so when you're going for your climb, what happens at what point in time?
So what happens is these hooks will start in, and then this powered hook will come up and grab the mid-rung,
okay,
and then pull itself up, and then snap on these hooks, and then this will deploy. These hooks will deploy out from this compressor, and then put it at the perfect angle, so this hook can reach back up to the next bar and grab on, and then do the same sequence again.
So coming in here at championships, what's kind of your optimized time right now for climbing? How long does it take to get up on traversal?
About 15 to 20 seconds.
Sure. Well, 51-72 Gators, once again, a phenomenal team here, looking great at championships. Can't wait to see what their performance turns out to be. So good luck here, and thanks a lot for taking the time to tell us about your robot.
First Updates Now is supported by the Milwaukee School of Engineering. MSOE offers week-long summer camps where high school students get to preview college by living on campus, exploring engineering programs, experimenting in labs, meeting with professors, and participating in fun group activities. Are you ready to experience STEM at MSOE? Visit msoe.edu/summer to learn more and register. Thanks to Stryker Careers for their support in this video. First alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in first are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.